All right, so we're going back to continue on with the uh, lessons for this pre-calc. Okay, simplify the trig expressions. And we said that it was trig is geometry with algebra put together. So here we can distribute distributive property. All right, let's do the distributive property here. See if we can get something from it. Secant theta times secant theta will be secant squared theta. That's negative secant theta. Positive secant theta. I just put it here because they're going to cancel out. And 1 times negative 1 is negative 1. Negative secant theta, positive secant theta cancel out. Secant squared theta minus 1. So hopefully you wrote it down somewhere of these identities. The one identity that I could already see for this one that it would look like would be tangent squared theta plus 1 equals secant squared theta. That's one of the trig identities. So if I just move this to the other side, I will get tangent squared theta equals secant squared theta minus 1. So this secant squared theta minus 1 will equal to tangent squared theta. And so you're saying, you're asking yourself, where do I stop? Where is it the simplest? Yeah, there's no real answer to what is the most simplified. This looks to be more simple than that. And so I would say this is more simplified. But that would be the answer to simplifying this. When it comes to these identities, it's not like it has only one answer. Like say x plus 2 equal to 10 or something, and then you have what are the solutions here? X equal to 8, where there's no other solution other than 8. No, I mean if you say it's anything else, then you live in some other world. You're making up your own math here. Okay. So let's simplify this one. Sine theta, I said before that sine theta, if there's anything as simple could be in trig, it would be sine theta. In cosine theta, don't complicate it more than it. It's as simple as it can be. Minus, that is called the what? What is this one's? What kind of is it? Odd or even? Anybody? Even, and if it's even, it will cosine negative theta will equal to cosine theta. Cosine negative theta is cosine theta. Okay. Sine theta, cosine theta, sine theta, cosine theta, multiplied. This is multiplied. What now? What can we do now? So, yeah, so like I said before, as you do more math and do a bunch of math, you become more mature and you know that these things are allowed, and you can work backwards. Like the same as when you get a fraction, say, you got 3/4. Where did 3/4 come from? Well, it could have came from this, no? It could have came from this. 1/4 plus 2/4. Let's take that back to elementary school. If you ever did some of this stuff, I'm doing it. See, this is what you learn in elementary school. If you have a common denominator, you add the numerator. 1 plus 2 is 3, and put it under the common denominator. So I'm doing this backwards, and that's what I'm going to do there. So if what I'm doing here, I'm going to do it here. So I'm going to say that sine theta over sine theta, cosine theta, and then this is going to be minus cosine theta over sine theta, cosine theta. What can we do here? Anybody, what can we do now here? Nobody?
Cancel cosine.
What can we do there?
Cancel cosine.
So, still going to be like, is that really more simplified? This is going to be what? Since these cancel, we're going to go, we have 1 over cosine theta. 1 over cosine theta is what? Is it secant theta? Secant theta, secant theta. And what is going to be then minus 1 over sine theta? CSC theta? So, one more time, you're like, what's the point? Or is this more simplified than that? Or whatever? So when it comes to like this right here, what is more simplified? Sure, whatever. For what we're going to do today is that you're actually going to verify. I'm going to say, is this equal to that? And verify it. So what we're doing today is much better than this. Because this one, you're like, I don't even know what do you want me to do? What's the final answer here? You just have to know what it simplified means, I guess. So verifying trig identities. That's what we're doing today. Continue on with the same things. And these are suggestions for verifying identities. Here's suggestion 1. Change all functions to sine and cosine if it's possible to do that. As an example, if you have tangent theta, what's tangent theta gonna equal to? All right, you guys copying this down. Let me slow down. Give you some time. All right. What is tangent theta equal to? Follow the suggestion. Say it louder. Tangent theta is what? Sine theta over cosine theta. It's just it's a suggestion, and maybe it works, maybe it doesn't, but hopefully it does in the problem you're doing. If you have a complex fraction, simplify it. Well, is this a complex fraction? As it is, it's not. This is a complex fraction that I'm going to give you right now. What is tangent theta? What is tangent? What? So say it again, somebody. What's tangent theta? Sine theta over cosine theta. So what I'm going to do is I'm going to change that tangent theta to sine theta over cosine theta. And then I'm going to change this secant theta to what? I'm going to change that secant theta to what? Anybody? 1 over cosine theta is correct. This is a complex fraction right here, this one. But what can we do now? You guys gotta talk somebody, please. What can we do now right there? Cancel out the what? Cosine theta with the cosine theta. So then cancel this, so it'd be sine theta over 1, which is sine theta. All right, so we got, you change the tangent theta. We're following suggestion 1, sine theta over cosine theta. And we got secant theta equals 1 over cosine theta. Cancel out the cosine theta, you get sine theta. Number 3. If you have two fractions with a plus sign between them, add them. Plus or minus, whatever the heck it is. Not multiply, plus or minus. You got this. Well, do we have a common denominator between these two fractions? Do we have a common denominator? Yes or a no? Yes. Both of these fractions have a cosine theta as a common denominator. So then this is going to go and become tangent squared theta plus 1 over the common denominator of cosine theta. What's tangent squared theta plus 1? Secant squared theta. So this is going to go and be secant squared theta over cosine theta. Maybe that would have been the next suggestion or something like that, but I'm just keep going. Here it's just telling you to add the two fractions, and I've done it here. Maybe we're going to do something else in next. Maybe I wasn't supposed to write this down. Okay, so that is combine them. It could be so many suggestions. Maybe I should just stop with these suggestions and just do them. Use any known identities to simplify the expression. So we got this now. Bring that down that we had over there. Now what do we do here? Well, I already wrote it down. I said tangent squared theta plus 1 is secant squared theta. And if this is secant squared theta over cosine theta, what else can we do here? See, secant theta is what? 1 over cosine theta? That's not even going to do anything else here. So 1 over cosine to the third theta? Let me see. Always keep an eye on your goal, think ahead. Let's get going with this. I guess that's as simplified as possible. You can't simplify this anymore. Maybe, yeah. All right. But let's go ahead and do some problems now. Let's go ahead. Let's go. All right, here we go. Okay. You will have to think about which one do you think is the most complicated side. Do you think the left side is complicated, the right side complicated? And sometimes they're both complicated. Here are the rules to this game here of verifying identities. The left side does not know what's on the right side, and you don't move things around. They're like this. That's why I have this all red. These things don't move around. It's not really kind of an equation where you move things around. You only work on either the left side or the right side. And to me, the left side looks complicated, and you want to simplify it to be the same as on the right side. All right, let's do that. So we're going to work on the left side to simplify it. And we leave that right side alone. Don't touch it. All right. So let's go. That is a co-function identity. What does sine pi by 2 minus theta equal to? Cosine theta. Somebody's saying it already. Look, all I'm going to tell you is that if you don't do the homework, then you, it's like the same thing. You didn't practice to play the game, so you're a little bit behind. So you should know what sine pi by 2 minus theta is, and that is cosine theta. What should we do with that tangent theta in the suggestion? Sine theta over cosine theta. And if you keep working at it and keep working at it, things simplify and they just do. What can we do? Cancel cosine theta and cosine theta, so the answer is sine theta. Is sine theta equal to sine theta? And we're done. Check. That's all there is to this. So you have to work on one side and make it look like the other side if it is true. Number 2. That's the check. Number 2. So, should we work on the left side or the right side? Man, if there's anything simple in life, it's the number one. Oneness of everything. No, the simple. You want to work on the left side, make it simplified. Let's work on the left side again, and follow some suggestions. Why do I keep using tangent so much? Tangent. Sine theta over cosine theta. What's cosecant theta? What's cosecant theta equal to? 1 over sine theta? Cosine theta, leave it alone. What are we going to do now? Cancel, cancel. What else? Cancel, cancel. What's the answer? Not 0. You're like 0. No, it's not. It's 1. And we're done. 1 is equal to 1. All right. Number 2 is done. Number 3. Number 3. Oh, number 3. Number 3. It's still pretty. Yeah. Some people are gonna want to do some weird stuff here on this one, but no. Yeah. Let me see. Oh, look. Yeah, I don't want to do it that way. Okay. What did we say secant squared theta minus 1 was it? I'm going to go with that one. I'm going to write it here on the side. What's secant squared theta minus 1 equal to? Let's go with tangent squared theta. So secant squared theta minus 1 is tangent squared theta. So yeah, okay, there's nothing to do here other than change it, and that is tangent squared theta. Change everything to sines and cosines. I'm gonna go that route. There's many ways to do this. There's not just this way that I'm doing. There's like 2, 3, 4 other ways of doing this. Tangent theta. What's tangent theta? It's gonna be what? Sine theta over cosine theta, but they're both gonna be what? They're both gonna be what? They're both gonna be what? And what's secant theta? What's secant theta? Well, don't worry about the 2 right now. We'll put a 2, but what's secant theta? 1 over cosine? So it's going to be 1 over cosine squared theta, no? Because it is. What can we do now? Cancel out the cosine squared theta, and sine squared theta over 1 is sine squared theta. We could have done it another different ways, but that's the way to do it. Let's go to number 4. Yeah, I'm always having to work on the left side. It looks the one to do, the left side, work on the left side. That's another one of these kind of problems. I should just, what's 1 plus tangent squared theta? Loud, I'm hearing somebody say it. Secant squared theta. So this is going to be secant squared theta over tangent squared theta. And we'll do that, that suggestion of changing everything to sines and cosines maybe. So then this is going to be what? On top, what's the top one going to be? 1 over what? 1 over cosine squared theta? And the bottom is going to be what? Sine squared theta over cosine squared theta? And we're going to do what now? Cancel out the cosine squared theta over cosine squared theta. 1 over sine squared theta is, so I'm going to skip a step because I'm running out of space here. 1 over sine squared theta is cosecant squared theta. There's that. So, these are still kind of easy. Let's see one that is a little more difficult shows up. All right, here we go. Man, the left side is complicated a little bit. Right side is complicated. Eesh. Anybody have any suggestions? Left or right? Right? Work on the right side? Okay, already, because I'm a teacher. I already see it. If you want to work on the right side, I know what to do on the right side. What do you think you should do on the right side? If we choose to work on this side, what should we do here? What did I do in problem number 1 of the warm-up? What was it in the warm-up? Is that conjugate, the idea of conjugate. Look, if I have 1 plus secant square or secant theta, do you know what conjugate means? What conjugate means is that 1 plus secant theta, the conjugate of 1 plus secant theta would be what? 1 minus secant theta. So this idea of conjugate works because in the middle it cancels out. And that's the reason why I'm going to use the conjugate. That's the way I'm going to do this. So I'm going to multiply the top and the bottom by what? We're going to multiply the top and the bottom by what? Huh? What's the conjugate of 1 plus cosine theta? 1 minus cosine theta. Well, really, because we're not doing anything to it. Is anything over itself is 1. So we're not. It's allowed mathematically. It's allowed. All right. So I'm getting already that 1 minus cosine theta. We'll get it on top. So then, because I'm already looking at this other side too. See, because I have it here, I need it there. So I'm going to have sine theta. And I'm going to multiply the bottom out. So 1 times 1 is 1. 1 times that is negative cosine theta. This is positive cosine theta. That's going to be negative cosine squared theta. What's going to happen in the middle? Cancel out. So negative cosine theta, positive cosine theta cancel out. 1 minus cosine squared theta. Okay? What is 1 minus cosine squared theta? Equal to? Somebody saying it? Sine squared theta. Why is it sine squared theta? Because it's the one fundamental identity. Sine squared theta plus cosine squared theta is equal to what? Is equal to 1. So if I move this by subtracting it, it will be sine squared theta. So 1 minus cosine squared theta should be sine squared theta. So then, as we continue, this is going to be sine theta times, leave it, don't multiply that one out, because you need that 1 minus cosine theta, which is up here. You want to get rid of the sine theta, and you will have sine squared theta at the bottom. That now you can do what? Now you can do what? Cancel out one of these sine thetas. So there's going to cancel this out and cancel this out. So now you're going to have 1 minus cosine theta over sine theta. And 1 minus cosine theta over sine theta is that right there, and you verified it. I mean, that's the way I guess even, that's the way I did it. Is there another way of doing it? I'm pretty sure there is. I'm telling you, there's other ways of doing it, but this is 6. All right, 6. Here we go. Which way? Which one? Which one? The left or the right? The left looks more complicated. So what do we do if it's a left? What do we do? What do we do if it's the left? What do we do? Anybody? What do we do? Change everything to sine and cosine? But what is it? Is it going to take you anywhere though? All right. Somebody says something like about that. Yes. I'll go with that one. Tangent square theta plus 1 equals 1. That's going to be 1 minus secant square theta. Is it? Is that what it is? Yes, that's what it is, no? We got what? Tangent square theta plus 1 equals secant square theta. So tangent square theta will be secant square theta minus 1. Yes, yes. Secant square theta, I got that backwards. Tangent square theta plus 1 minus it. I got that backwards. Alright. It's supposed to be secant square theta minus 1. Yeah. Over secant theta plus 1. That's the difference of squares, everybody. Here we go. This is called a difference of squares. It's just the same as x squared minus 1. See, I'm telling you, you got to know a good amount of algebra. What's the answer to this? How do you factor this out? We're not solving it. We're factoring it. What's this? X plus 1, x minus 1. That's the difference of squares. X plus 1, x minus 1. Why? Because it's going to be x squared. Again, negative x, positive x, minus 1. Cancel out. X squared minus 1. So I'm going to do a difference of square there. If I do a difference of squares, I don't know, it's going to take me somewhere. Difference of squares is going to be what? Secant theta plus 1. Secant theta minus 1. Over secant theta plus 1. Put parentheses around if you want. What can we do now? Cancel out. So I got secant theta minus 1. How is this not that? Okay. Make it a more complicated. This is what we're going to do. This is what we're going to do. What's secant theta equal to? What's secant theta equal to? 1 over what? 1 over cosine? Why? Because that is cosine. I want to match it up. See, I'm not blindly doing stuff. I want it to equal to that. And for it to equal to that, I better have some cosine theta. So this is going to become what? 1 over cosine theta minus 1. So now, I'm going to do a common denominator. What does this fraction have that that one's missing? Cosine theta. So what you do at the bottom, you do at the top. So don't I have a common denominator now? If you have a common denominator, you can put it under one of them and subtract the top, no? I ran out of space, I'm going to go over here, so I'm going to write down 1 minus cosine theta, 1 minus cosine theta, and put it under one of them now, cosine theta. And that is true. That is true. So I don't know if I finally did one that is not the same as the way I have it up here. Let's see. Let's see. Let's see. What do we got here? What? 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 Okay. What? Whatever. So what I'm trying to tell you here? That is correct. I think it is. And what I did is correct. They're both correct. Because we verified it different ways. Let's go. Last one, I think, today. Number 7. Which one is the one? Which one? The left or the right? Which one is the left or the right? Sine over cosine. I'm gonna work on the left side. I think. Am I? I don't know. Does anybody have any idea what do you left or right? Left. If we do left, what do we do? Put it in the simplified to sines and cosines, no? So secant theta is what? 1 of cosine theta? Tangent theta is what? Yeah. But is it going to take me anywhere though? Tangent theta is what? Sine theta over cosine theta? But it's not taking me anywhere. Like, what are you gonna? It's not matching up at all. What are we gonna do? If we do this, what do we do? 1 plus sine. Well, yes, it is. But is it going to take me anywhere? How is this equal to that? Multiply by the conjugate? Multiply by the conjugate? Don't well, do multiply the top, no? Let's multiply the top. And you know, after doing this for so long, you'll know that the middle is going to cancel out. I'm not even, I don't want to write it down because it's going to be positive and negative sine theta and minus sine squared theta. Over 1 minus sine theta times cosine theta. Well, now what? We do have this 1 minus sine theta. We do have this already. So we need to work with this stuff here. What do we do here? What do we do? What do we do? We got to work with this. Because we do have 1 minus sine theta. What's the fundamental trig identity that we say? What was it? Sine squared theta? Sine squared theta plus what? Equals to. So what do we have? 1 minus sine squared theta? 1 minus sine squared theta, move it over. So what is it going to be? Cosine squared theta. Cosine squared theta. We'll put cosine squared theta there. It's going to cancel with the bottom and we're done. So 1 minus sine squared theta. So cosine squared theta. I ran out of space here. So we're going to have cosine squared theta over 1 minus sine theta times cosine theta. A cosine theta with the cosine theta cancel out. And we got cosine theta over 1 minus sine theta, and that is true. Okay. Look, I did it the other way. I made that look like this. So we could have done that conjugate thing here at the top. And whatever, you get that, and then that, and you go do diff to squares. No. Yeah, it's backwards. What? Oh, and then separate them. 1 over cosine theta over that. 1 1 over cosine theta is secant theta, and that's tangent theta. Having fun yet? No? All right. So we are done. And